Hello this week from the bustling metropolis of Makarora, population 45. So we're going to do a bit different things this week because I am on a trip and getting rained out. But as usual, we have two papers, and this week the papers are about domain-specific languages, broadly speaking. So we have one about quantum programming, and so that's clearly a domain-specific language, or maybe a more general domain than normal programming. And the other one centers on the domain of policy languages for ensuring that programs don't do anything bad. So I have more notes on the policy language because I have more space to write them. So let's talk a bit about the policy sandboxing paper. So what we have here in this paper is both a static analysis and a synthesized synthesis for a domain-specific language. And so it studies what the state of the art is in a domain where there's manually written programs, and then it automates program writing based on a set of observations they make about these policies that get manually written. So the main idea is to constrain the allowed behaviors of software based on what is present in the code. And they have specific definitions about how they have valid policies. I guess this wouldn't catch purposely inserted backdoors, but you would see them, I guess, by seeing what happens in audits, which could be visible in diffs of the policy. The static analysis is of a simplified C-like language with arrays and no pointers. It also tracks specific array elements. It's an interprocedural summary-based analysis. For the policy synthesis part, it converts a set of potential calls, which the static analysis gathers, into a security policy. And so there's top-down search over templates. This is an instance of CGIS, or counterexample guided inductive synthesis, which is an important idea in programming languages research for the past 15 years or so. And probably would be good to talk about this in some detail in this week's presentation. There's a pretty good example in section 5.2. The evaluation is pretty strong, and so the speaker should probably talk about that in some depth. Note the ablation study, which compares the results of this work to other versions of this work which are less powerful. And so it answers the question, did the analysis figure out more than it needs to, or does it need to be this powerful? Moving on to the second paper on quantum programming. So what we have here is, again, a domain-specific language for programming quantum computers. And so it's based on this type system which prevents you from writing programs which are unphysical or cannot be physically realized on a quantum computer. So there's a linear type system which goes back to what we saw in the first part of the course about Rust. And there's also the notion of uncomputation, which is new to me. And so there's programming language concepts which are embedded in the type system as well as a linear part of it. Such as marking the concept of being quantum-free or classical, measurement-free, and there's also, of course, the notion of constants, which is pretty old. So the presentation will of course need more background material than usual because there's the whole quantum programming concept, which we are not that familiar with in the most part. But the speaker for this week's presentation is also doing their project on quantum on this paper, so they should be familiar with this concept. And so I expect that we'll have good explanation of these concepts from someone who knows them, which is not me. In particular, the tensor product and the Hadamard transform are things that we would really benefit from learning from. So as with many programming languages papers, there's a core language, and the properties are shown for the core language. And that makes it much easier to understand, to present the system. Otherwise, it would be like a 400-page paper, and we don't see that. And there's a lot of appendices here, which, of course, we wouldn't usually read, but they present all the details. All right, so that's my introduction to the papers this week, and we'll talk in a few days. Thanks.